Hello students, welcome again in our PMI chapter, Principle of Mathematical Induction. In the part 3, students, today I am going to very interesting numericals for you. I hope you understood there are the two parts and step 1, step 2 and step 3. Yes, what is step 1? If n equal to 1, then P1 is true. Second step and third step are combined. Second step is if pk is true, then we will prove in step 3 p of k plus 1 is true. That is the main principle of our PMI chapter. Yes students, today I am going over question for chain, continue exercise in the PMI related. So same question I just explain you. Here step 1. If n equal to 1, so what's your LHS? 1 upon 2 into 5. That become 1 upon 10. And RHS also same. N upon 6n plus 4. Students, here only you put down your n. 10. So LHS is equal to RHS. It means P1 is true. Your first step have been done. Now I am going to second one. Step 2. If pk is true. Yes students, you just forwarded your step. These are full term in the k. So 1 upon 2 into 5. 5 into 8. 8 into 11. Till last. Here 3k minus 1. Into 3k plus 2 and is equal to k upon 6k plus 4 for k belongs to natural. And now step 3, which is to prove p of k plus 1. Students, this full term again write down, but k change in k plus 1. So 1 upon here 2 into 5. 5 to 8. Similarly, just here your turning point now start. 3 k plus 1 minus 1. 3 k plus 1 plus 2 and is equal to same as. Now I start my LHS and easily complete our RHS. So what's your LHS? Here I start now. That's your LHS. Full term I again write down. 1 upon 2 into 5. 5 into 8. 8 into 11. Plus 1 upon 3 of k plus 1 minus 1 into 3 of k plus 1 plus 3. Plus 2. Students, you just think out. Here 1 reverse term, 1 back term, only 1 is subtracted, and this equation I write. So 1 upon 2 into 5, 5 into 8, 8 into 11 plus, here I go into 1 reverse term. Here k plus 1 just change in k, minus 1 is same as, so you getting only 3k minus 1. 3k plus 2 and this data is as it is, plus here I write down below that 3 of k plus 1 minus 1, 3 of k plus 1 plus 2. Now students, these are, that is your step number 2. This R is balancing to our terms and that value k upon 6k plus 4 I just write down there. So is equal to 1 upon 6k plus 4 k upon and these are same, k plus 1 minus 1, k plus 1 plus 2 and mention that because pk is true for related this to my applications, I show up pk is true. Now simplify it. It's very easy now. Major calculation is done. So students, I just calculate this intermeters and after that take out LCM. So K upon, here 2 common, 3K plus 2 and here 1 upon, how much? 3 ones are 3 minus 1 plus 3 minus 1, it is plus 2 and again 3K plus 3 plus 2, these are 3K, 3 plus 2, we get 5. Now students take out LCM, either common, I taking common, K by 2, 1 upon 3K plus 5. Now over that, simple, you take out the LCM and happily this RHS is done. Students, that is your my RHS. Correct? Yes, 6K plus 6 plus 4, it is 10. So here I am taking LCM, 3K square 5K by 2 here, 3K plus 5. These are LCM taking. Now splitting. You get just 3K square. 3 and 2 6 are, but I want 5. So 3K plus 2K. And this same is common K. One of the common 3K, definitely K plus 1. 2, definitely K plus 1. Yes, students, this is the oversum. This your I is a yes. So only I just remove that one. For checking only, I just remaining that steps. So 1 upon 3K plus 2. Here K plus 1. 3K plus 2 upon 3K plus 5. Look at that. This here cancel. 2 1 sheet inside. So it is finally done by 6K plus 10. Check. That is your RHS for step 3. The last write down therefore it is RHS. So P of K plus 1 is true. So what you return? If Pk is true, then P of K plus 1 is true. And here students, our this question and the ending of this you must be write down by PMI. Pn is true for every natural number. Okay? Yes students, here done 10th one. Now I going ahead 11th. Now students continue ahead. Next question 11th. Same pattern, 1 into 2 into 3. There are 3 terms given. So, start here. Similarly, step 1. If n is equal to 1, so what's the LHS? 1 into 2 into 3, 1 by 6. Now, what is the RHS? n with n plus 3, 4 with n plus 1, n plus 2. You only put down there n is 1. So here 1 plus 3. Similarly here 1 plus 1 and 1 plus 2. It is 4 by 2 and 3. It's 1 by 6. Both same. So definitely we can say LHS is equal to RHS. So P1 is true. Now secondly going to same step 2. If Pk is true, so students, what is the P of K? This P of n fully I show in the K terms. So 1 2 3, 2 3 4, same write down. Okay, last 1 over K. K plus 1, K plus 2 and is equal to K with K plus 3, 4 with K plus 1, K plus 2. Don't worry students, it's a lengthy steps but easy. Step 3. To prove P of K plus 1 students. So 1 upon 1 2 3, 2 3 4. Here just I change. In k, k plus 1. Here k plus 2. And here k plus 3. And is equal to k plus 1, k plus 4, k plus 2, k plus 3. Now students, we going to our slowly LHS term. This is our LHS. Yes students. LHS 1, 2, 3, 2, 3, 4 and here same. So only you just here think out to one back step. Students, this back steps necessary here k plus 1 and k plus 2 and that contain to your step 2. So I am just going ahead one back step, this one. So I just start 1 upon 1, 2, 3, 1 upon 2, 3, 4 plus here one back step. So 1 upon k plus 1 and k plus 2 plus this same is k plus 1, k plus 2, k plus 3. And here students, you just focus about that. That is your step 2. This step 2 value known. I just put down there k plus 3, 4 with the k plus 1, k plus 2 and this same is. Yes students, one more time I repeat you. This full value is that your step 2, that one. And that value I am putting there here and mention because pk is true. Here students, after that I am going to common and easily simplify our further steps students. These steps are further steps I write down here. Yes. So only common checking and easily simplify in your answer. So students, these steps I continue here. Now you take the common. How many common are there? Yes, k plus 1, k plus 2, remaining are k with the k plus 3 by 4. And here students, what is remaining? K plus 1, k plus 2 already take outside. Remaining I have k plus 3. Now simplify. Yes. So k plus 1, k plus 2. Here k plus 3 whole square. Take out the LCM. Plus 4 upon 4 with the k plus 3. Yes students, it is a very big expansion in poverty 3 level factorizations. Don't worry, but I give you a shortcut method. So 1 upon k plus 1, k plus 2. Here k square 6k plus 9 and upon same is. So finally getting students your value k plus 1, k plus 2, here k raised to 3 plus 6k square, 9k plus 4 and upon down same is. Now students, this is a simplified power 83 is big one. Don't worry, I give you shortcut method. Students, this shortcut method is easy. That's your RHS, you know that. Yes. So what the factorizations related to your RHS? This is my answer. RHS. So sometimes in exam also, you students write down direct. Look at that, I write down direct. This answer here show up k plus 1. Otherwise, you going to step method for factorization. but it's very big. So this answer I directly write down. Again you write down k plus 1, k plus 4, 4. I give you shortcut method, students. Check. K plus 1 present. No. K plus 2? Yes. 4? Yes. K plus 3? Yes. What is the accent here? K plus 1. So I write down k plus 1 upper, k plus 1 down. These three are the factorization of this one. Finish. Again you cut and finish and write down RHS. Look at it, students. Here I nothing do, but answer is over. Because this answer I know, that's why I written that. Again reverse side and check out what is the left term. Left term write down, upper and lower, and again cancel. Indirectly these three are factorization of power 83. Now finished. Yes, it is your P of k plus 1 is true. Therefore, if Pk is true, then P of k plus 1 is true. And last write down by Py. Pn is true for every n belongs to natural number. Students, one more time I repeat to you. These are known answer, that's why I written and reverse step right. Either you can do your factorization by long division. It's very big steps. Okay? Yes, now I will next one. Now students, after that 11th I am going to 12th one, which is the most IMP sum. Many times asking in the exam. So most probable maybe asking this year also. Now I am going to say our step 1. If n is equal to 1, what is the LHS? Only this first term A RHS. You just put down R is equal to 1. So A into R is to 1. Yes, they are touching. Only you have to. LHS is equal to RHS. So P1 is true. Now step 2. If Pk is true, so what is the P of k? Yes, only and only this full term AR square. AR is to k minus 1 is equal to R is to k by R minus 1. Only just students I change in place of n, which is k. Now step 3. What's the step 3? Necessary write down. To prove P of k plus 1. You just forward. Here in place of k, we write down k plus 1. So AR is to k plus 1 minus 1. Same k plus 1. And student this cancel. Now easily I start my LHS, which is AR square, and here AR is to k. Just think out again. I same asking what is the one back term for this back term. So AR square, AR is to k minus 1. And here AR is to k same, and these are step number 2. These are step number 2. This value I put down here. So therefore the running R is to k minus 1, R minus 1, and other is same, AR is to k. I mentioned there by Pk is true. Necessary to write down using that Pk is true. Yes, students. Now easily you take out the LCM. AR is to k minus R minus 1 upon. So AR is to k minus a. Here a raised to k into r raised to 1 and minus this multiply a raised to k upon. Now students check, your first term and last term is cancelled and there is same powerity addition. So a r raised to k plus 1 minus a common by r minus 1. Yes students, that's your RHS. Check. This is your RHS. Main step are these only and easily done. Last I write down. Therefore, P of k plus 1 is true. So, if Pk is true, then P of k plus 1 is true. And last I direct written. Therefore, by PMI, Pn is true for every and belongs to natural number. Necessary write down. Here what I written, but you write down necessary. Okay students, these are IMP question 12 done here. Now students, we are going to slowly one more sum. It's a very easy sum. Pn given and prove that by PMI. So I am going to here students step 1. If n is equal to 1, what's the LHS? Yes, our LHS is 1 plus 3 by 1. And what's the RHS? It is n plus 1 square. N is 1, which is 2 square. And how much? 4. Now, therefore, we can say LHS is equal to what? RHS. So, E1 is true. Your first step. Happily done. Now, step 2. If Pk is true, so what is the P of k? Full term. Again I show in the terms of k. 1 by 1. And here 1 plus 2k plus 1 by k square is equal to k plus 1 whole square. And step 3, which is to prove. What is the P of k plus 1? Just only k I change in terms of k plus 1. So, that's same. Here also same. Continue. Here 2 of k place you change k plus 1. So here 2k plus 1 plus 1 upon k plus 1 square, and here plus 1 of plus 1. Indirectly you can gain k plus 2 whole square. Yes students, here only I k show out k plus 1. Here also same. Now I am going to LHS. This is the main step. Mostly here students taking this step. So 1 plus 3 by 1, 5 by 4, 7 by 9, and here same is k plus 1 plus 1 by k plus 1 whole square. Students, here just think out one back term. Yes, you correct think about that. 1 plus 3 by 1, 5 by 4, 7 by 9. This k plus 1, I just write down k. This same is, and here what? K. So, my term is 1 plus 2. Here k plus 1 by k square. And into this as it is upon k plus 1 whole square. Yes students, this total value up to that, it is what? Step 2 up to that 2k plus 1 by k square, and that value is what? K plus 1 whole square. So our sum is done. K plus 1 whole square, and remaining are 1 plus 2 with k plus 1 plus 1, k plus 1 whole square, and I written here because pk is true. Yes students, now take it LCM. So k plus 1 whole square, here k plus 1 whole square plus 2k plus 2 plus 1, and down term is same as this cancel. Further, I have only k square plus 2k plus 1, 2k plus 3, and that also k square plus 4k plus 4, and which is k plus 2. Check, that's your RHS. Already I show in the step 3. That's my over sum. So that is your RHS. So what is your last? P of k plus 1 is true. It means what is your last? If pk is true, then pk plus 1 is also true. And last line written after that, mostly students, by PMI. Pm is true for every m belongs to natural. Now students, we go in next question, 14th one. This also same, all term given in the product form, same as 13 and 14, parallel sum students. So in step 1, if n is equal to 1, yes, what's the LHS? 1 plus 1 by 1 RHS, n plus 1. It's very simple sum. So LHS is equal to RHS. It means P1 is true. Now step 2. If pk is true, so what is the p of k? 1 plus 1 by 1, 1 by 2, 1 by 3, and here 1 by k. Here k plus 1. Similar going ahead. Step 3, which is to prove p of k plus 1. Students, same I just explained. 1 plus 1 by 3, and here now one changing point. This is a main point. K place we can write k plus 1, and here also k plus 1. This k place we write down k plus 1. Indirectly you can guessing here how much? K plus 2. Now LHS. 1 plus 1 by 1, 1 by 2, 1 by 3, and here same is k plus 1. Students, here just write down one back step. Yes, we correct think about that. Here only k. So we have to. Yes, we have to. This value, which is 1 plus 1 by k, and remaining are k plus 1. And now students, here this term I just show out. That is what? It is your step 2. And value is what? Step 2, k plus 1. So you mention by that k plus 1 into the same as, because pk is true. Now simple taking our LCM. So here k plus 1, k plus 1 plus 1 upon k plus 1. Kaching, kaching. It is k plus 2. RHS. Check. That is my RHS. So we can say therefore pk plus 1 is true. Therefore, if pk is true, then p of k plus 1 is also true. So last I write down by PMI, principle of mathematical induction. Pm is true for every n belongs to natural number. Yes students, this 14th sum and 13th sum are easily over here. Yes students, then 13 and 14 done, and also this part is students done here, and further explanation for this chapter students I explain you in the next part. Okay, bye bye, see you.